Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
Hey everybody, welcome back to another festive episode of the Flowline. Matt Offenbacher and I here, back again in the studio. It's potluck week here at AES, meaning we're celebrating the holidays and we're doing a potluck. And Matt's decided to wear green pants with his, I think, which is a red shirt. I'm colorblind. My kids tell me I pick the wrong colors all the time.
Yeah, it's reddish, magenta.
Yeah.
I'm not great at this stuff either, right? I'm just an engineer who hopes he doesn't clash too badly. But yeah, got my bold green pants for Christmas. We got the potluck. Yesterday, we had a contest where different folks decorated their offices.
Oh,
and
I missed it.
I got to be one of the judges. And, our accounting department does it big.
They do. They're very big on that stuff, which is cool.
Yeah, and they were moved down to the third floor, so you kind of go around here, and there were some people, Lana had a really great setup, and she was even like, hey, I'm going to start playing some music, create some ambiance. Will you look at this? Because I got to be one of the judges.
The full experience.
Yeah, and then Candy, I'm going to leave somebody out. She had a really nice setup in her office. And then downstairs, we went to accounting, and Sherry was just like over the top, and she's like, I got 3 boys I'm looking after. We do Christmas big here.
What?
But Christian and Elizabeth sort of did a joint thing where they had wrapping paper covering their tables, and they had Christmassy stuff on the TV, and it was really well done. So a bunch of people went all out, and I thought it was super cool.
Oh, that's great. I wonder if anyone's gonna go as far as getting a mini snow machine. I picture walking into an office, the snow's falling, it's kind of dark.
Rule nothing out on the 3rd floor, I'll say that much.
Yeah. No, I'm trying to burn up some vacation days, and so I was out yesterday. But yeah, it's fun around the holidays. Is neat. The office is always in good spirits, and everyone gets in here, knocks out their work, and if there's any few minutes here and there, we get festive, and so it's fun. I was actually walking in the parking garage today, and for some reason I thought it was our potluck that smelled so good, which I was like, well, that'd be weird because it's on the 8th floor and I'm in the parking garage. But someone was doing some cooking in the parking garage.
Huh.
It was smelled like a brisket and barbecue and all kinds of stuff. It was odd. I was asking people, and it's like, hey, was it someone cooking in the parking garage? And so I don't know if it was the restaurant from downstairs, but someone's putting on a big spread. You could just sense it, and so I started drooling and came to our office with no food, and so I was slightly disappointed. But the potluck,
we can stop by later.
Yeah. I'll go roam the parking garage looking for food. Sure, that'll go over well. Anyway, moving on to Drilling Fluids World. Matt, an episode that you came up with, which we don't typically dive too hard into the weeds of solids control. However, solids control is a big part of what we're a part of, right? I say what we do because we don't actually do solids control, but it's extremely important in drilling fluids. And so the title for today's episode is a Decanter Centrifuge. And so at the end of the day, man, I think it'd be good to run through this. And if there's any solids control gurus or experts or specialists out there that want to add to this, would be great. But we're going to do our best to describe it and outline a few things when it comes to Decanter Centrifuge. Matt, what do you think?
I think it's good. I go back to trying to think through the fundamentals. I was doing a little bit of homework. Some stuff came up on centrifuges the other day, and so it was like, okay, well, let's do something on the basics. It would be cool if we could rope in some of our friends at a solids control company to maybe give us a more advanced discussion.
Sure.
So this will be sort of a nuts and bolts thing, but here we go.
Excellent. Well, let's go ahead and just firstly describe very basically what is the role of a centrifuge and how does it work?
Well, it's solids control, of course, which, our customers get mad when there's solids in the mud, but we didn't put them there. They're going to end up in the drill, just through the natural drilling process. And you've got a whole series of solids control equipment. Maybe we'll cover some of those other parts, but, your shakers are your first line of defense. And then, you have also your sand traps below it, which is kind of like relying on gravity for some heavy things to fall out. So bigger particles and that sort of thing. And then your fluid is, into the active system where you'll, if you don't do anything to it, it's going to flow down those pits and then ultimately get sucked up by the mud pumps and go back down hole. But, shakers can only take it so far. And one way, or one of the primary ways, shakers do mechanical separation, where if it fits or doesn't fit through a screen, that's one thing. The other technique we really lean on heavily is gravitational separation. So if you imagine in really basic setups, you might actually just have settling pits, or and that it maybe there's a little berm in between, so they have to go the long way around. Like time. The problem is we don't have time, and we don't have all that volume, to let fluid just do that and separate with gravity.
Yeah.
So we want to speed it up, which is what a centrifuge does. We pull fluid in. We spin really fast, and the idea is that when we're spinning that fast, the solids want to move to the outside, and we scrape them out and separate them, and then we get this other material, and we can put it back in our mud system, and our fluid is hopefully cleaner. So we start with our shakers, and then a lot of times we're moving to the centrifuge, and I guess most people would say that from a cut point, 10 microns is about what you're going to get. Are there ways to get finer than that? Possibly. Depends on the mud, depends on the conditions.
Right.
All the phases of the moon, all that stuff. So, and then once, if a centrifuge can't take it out, it's probably dilution from there on,
Yeah. When it comes to the centrifuge, and to give people an idea, you said we spin it. Unless you've been on a rig, maybe you think we spin. Like, what are you spinning, and are you physically spinning something? So just give a rough sort of a visualization of what a centrifuge is, how big, and perhaps how fast this thing spins.
Yeah. So I think like first you can pull the fluid from wherever, right? You're probably pulling it from a tank on the active, maybe just past sand traps or whatever, and you're pulling fluid and you're transferring it into this centrifuge with either a centrifugal or progressive cavity pump. So centrifugals, we see those pumps everywhere. The only problem with those is it's not as consistent of a feed, right? So that consistent feed can be quite helpful in separation efficiency. Progressive cavity pumps cost more money, but you can really dial in your feed rates. But you're moving that fluid into the centrifuge. And what's going on in the centrifuge is you have this feed tube, and the fluid goes into the centrifuge, into that feed tube, and it hits basically like a plate, and you've got this big bowl spinning really, really fast. This is enclosed. It's not, you can touch something spinning, and we're talking 1,600, 3,000 RPM, real fast. And so the fluid, the heavier parts of the fluid obviously want to go outwards, and the lighter stuff kind of stays a little closer in. And then inside there, you've also got an auger, and the auger, it actually has some windows in it, so liquid can pass through, but at the very edges, it's effectively scraping those solids as they've come up against the outside of the bowl.
Right.
And it's rotating at a slightly different speed, but it's ultimately scraping those solids in kind of a screw configuration up to one side, and the liquids basically can fall out the end on the other. So it's scraping those solids. Those are falling down a sled into usually an open top or what have you. The liquid is going the other way, and usually through some piping or what have you, and a lot of times it just drops into your pit again.
Right.
That bowl, we're looking for big G-forces. That's why its size can vary. So bigger bowl should give you higher G-forces, but you can also adjust the speed.
Right.
And then a longer bowl gives you more retention time. So more time to process, hopefully more time for it to be exposed to that high gravity and get better separation. And there's some other kind of things, you can even set the depth of the amount of fluid you're going to allow to accumulate. So,
right.
Deeper, what you'd call beach, maybe you get some longer processing time, and you can adjust these things on the weir plates to change it.
Yeah.
That's kind of, I don't know anybody who's actually done it in the field, per se. You could. I mean, people claim it only takes a couple of hours, but it's a much nicer thing to do in the shop.
Right.
You know, and in essence, you know, these things, how powerful are they? You know, 100, 150 horsepower. Are they? Can you change the speeds, or is it you turn the machine on and it just does one thing? You know, when we're actually at the rig, when everything's kind of rigged up, you know, usually we've got some sort of variability. So we can hopefully adjust how much fluid we're putting in at a time, which slower feed rate, hopefully better separation.
Yeah.
However, that can also depend on your bowl speed and your auger speed and the differential between those two, right? So if they're moving closer to the same speed, it's going to be in there longer. The material's going to take longer to get scraped out, right?
Yeah.
Let's see what else.
Well, and like in saying all that, there's clearly a bunch of variation on setup and sort of design. We as mud companies don't dictate that. The Centrifuge company will look at the mud program or get an understanding of what systems are being used, what mud weights, and then they kind of have a setup designed to meet that sort of those requirements, depending on the mud design. And so, but that can vary quite a bit, as Matt's alluded to. I mean, there's different speeds or different sizes. You can have maybe 2 on location. When it comes to that, we don't typically have like a huge say in, well, you need this and you need that. And some customers might say, hey, what kind of centrifuge do you recommend, or based off your experience? But with that being said, this is something that's, because the listeners out there might say, well, which one do you use? Because I'm hearing a bunch of different setups. It depends, right, on the fluid and the type and all that. I
mean, how much solids are in the mud? You know, if you're drilling with slurry, you can be really, really aggressive because you're not worried about throwing out all your bayrite. You know, there's other parts of the conversation there for sure.
Yeah.
And I mean, the flip side of it is, you know, we end up with a lot of, okay, I want a centrifuge out there, but then it's like, okay, is it fully variable? Like, what settings can I change?
Mm-hmm.
What settings should be changed? You know, there's certainly ways to set up a centrifuge where if you don't want to mess with it a lot, you can basically just shoot fluid right through it, and it's not actually processing anything.
Yeah.
There's certainly, even just if you have a solids control hand out there, depending on their training, depending on, you know, some of them are like, look, I just empty out the open top. Like, the centrifuge is there, and I turn it on when you tell me.
Yeah.
So, you know, depending on the level of understanding of how those things work, we're not in charge of the equipment, but we try and play ball, and you know, we even have somebody who will go out and look at equipment. But a lot of that stuff, just to avoid the finger pointing stuff, we'd rather talk to we'd rather show up on site, talk to somebody, have a healthy conversation, and leave.
Yeah.
Then go back to the customer's office and, you know, look, your solids control equipment isn't operating well. Make it a big thing about it.
Yeah.
Because ultimately that undermines trust and creates some other issues in the field that we just work better together that way. So, I mean,
yeah.
Shout out to Lionel, who has a lot of, I think, developmental conversations with folks who may not be aware of even some of their own equipment, how it could be best used, and he's got a ton of experience to share.
Yeah, no, that's true. When it comes to when you start drilling with heavier muds, a lot of folks have probably heard the term bayrite recovery. Let's cover what that is, which obviously plays into a centrifuge and bayrite solids control.
The big challenge with gravitational separation is gravity does not care about what your material is or how expensive it is. It is by mass or specific gravity. So our bayrite's going to be our heaviest stuff. And as we have more bayrite in our mud, the challenge is if I just run the centrifuge full bore, all I'm doing is pulling bayrite out of the system. And in light of that, what we want to do is there's going to be an economic inflection point, and there can be an argument about mud weights. I think that changes as the price of bayrite continues to increase. But let's say it's 12 pounds. Can we throw that out there without people getting too mad?
Yeah.
Somewhere in that neighborhood, you'll say, okay, what if we do a big bowl centrifuge ahead, and what I'll actually do is instead of taking the solids that come out on that sled and putting them in the open top, I'll dump that back in the mud system. because it's mostly barite, right? It's the highest specific gravity stuff, so it's going to be thrown out first. Then I take the material that comes out of the basically liquidy phase, and I move that directly into another centrifuge. And that other centrifuge is a high-speed centrifuge that's actually now trying to separate out drill solids. And I mean, there's still going to be some barite in there, but kind of polish everything off. And this one will be more rigged up conventionally, where the solids come out and they go to disposal, and the liquid is returned to the active system. And so there's lots of debates about when and economic inflection points, but when you reach a certain mud weight, it's probably worth it. I know you've worked with a lot of customers on this, Justin. Just running the numbers, helping to get an understanding of where and why it makes sense.
Yeah. It's like any piece of equipment out there. If you can have all the best tools in the shed, but if you don't have someone properly running it, maintaining it, and fine tuning it on a regular basis, it can be just a bunch of wasted time and money. And so I've seen barite recovery work wonders, and then I've seen barite recovery questionable. And so it depends on, again, a lot of factors. But in theory, barite recovery at past a given mud weight can save you a ton of money and just makes your fluid run so much more efficiently.
Absolutely.
Talk about dewatering or flocculation, because that's one that we don't do, well, depending on the basin, but it's something worth mentioning.
Well, yeah, I mean, so when you think about gravitational separation, it's not just the weight of something, it's also the size of the particle. And so what if we're able to, flocculants, what they do is they cause solids to agglomerate. And so this is water-based mud, but let's say we inject some polymer into, near the feed of my my centrifuge, and I'm actually causing the solids to agglomerate, and then I'm centrifuging. Well, I can gain some efficiencies there. Everybody, well, can I dewater oil-based mud? Kinda. I mean, so there's technologies that will allow you to do it, but in essence, what you're actually doing is you're water wetting the solids. So you're water wetting the solids and kind of breaking down the emulsion a little bit to strip those out, which can be a bit more of an intensive and expensive process. And we've discussed some of those technologies, but ultimately a lot of it is, if you're tank locked at a mud plant, it might be something worth looking at.
Yeah.
In the field, there's still it's still a little, I don't know, fumbly, is that a word? So that goes back to sort of a lot of challenges with making that work at a field level. And so, that's one way to improve the efficiency of your centrifuges at a relatively low cost if you're drilling with water-based mud.
Yeah.
And we've talked about high spurt loss fluids and how helpful they can be at drilling rates. Well, dewatering can be a really important way to limit dilution and keep those solids out, to make sure you drill fast. And then the other technique that you can use is viscosity is another factor in separation, right? Because it lowers the settling velocity or gravitational separation. So it may be that you might inject base fluid into the feed to help thin the fluid a little bit to improve that separation. Now, of course, that's going to depend a lot on what your setup is and what you're allowed to do. We did it all the time offshore. And a lot of what we were doing offshore was we had vertical cuttings dryers and we had recovered oil, and we were pumping that back in to cut the mud a little bit and centrifuge it that way.
Okay.
But you can also make the fluid thin before you process it. So I think that's another one worth keeping in mind. But on the broad scale, one thing I think people don't realize, or many of our customers want to consider more, is you're not processing the whole active system all day. You might get through 10%. It depends on your feed rates, of course.
Yeah.
But there's a lot of, can I turn it on? Can I turn it off? And normally when you turn it on, you're probably not turning it off. And even the number of centrifuges, you may have 2 if you're trying to go really aggressively to manage your volumes. But what would you have to say about that, Justin?
Yeah. It depends. Well, so depending on your pump rate, right? There's like the reality is you only have a certain amount of processing volume, right?
Mm-hmm.
Like, if you're on surface pumping 1,000 gallons a minute, there's a small chance that you'll be able to process 1,000 gallons a minute. And I'll be honest, since not being on a rig in quite a while, I don't know if the feed rate or like the volume has increased on what they can process per minute, but the reality is you're having to compensate, and so that's why you're having to dilute, obviously, to build volume on top of it. But there's I don't, and kind of thinking of that, I'm kind of surprised that maybe someone hasn't come up with a big enough centrifuge, which I'm sure because of the cost and maybe operators sort of mindful of what they're paying. But it would be neat to where you could process the exact amount that you're pumping on the rig. So if you're pumping 400 gallons a minute, you're processing 400 gallons a minute. I've seen where, depending on the size and what you've got on location, some people run it as long as you're circulating, you're running the centrifuge. Mm-hmm. But then, if all it's doing is kicking out barite because it's not running efficiently, well, then people might cycle it. And so cycling it, a few hours on, like hour off, because then that also depends on your solids control efficiency on the rig itself and the shakers. And so, again, there's no perfect playbook. It kind of, you run it to sort of match what you're doing at the rig and kind of finding that balance of making sure you're running enough to make it worthwhile. And so that way you're getting, the bang is hopefully worth the buck. But then you're not running it too much where all you're doing is just having to add products back in. Because if you've been already, it might be working good halfway through the well, and then all of a sudden something doesn't quite work as well, and next thing you know, your effluent, which is the fluid that it's pumping back into the system, is trash. Mm-hmm. And so then you're like, well, shoot, maybe we shouldn't run it as much. And so you're constantly tweaking it because it's a piece of machinery that runs at, insane RPMs, and so things eventually wear out or break down or need tweaking. So it's a fine, like, you can't just set it and forget it. And maybe now, maybe people out there are like, well, no, nowadays you can. And I don't remember ever seeing that, nor have I heard of it. But the cool thing is there's some folks working on remote, sort of remote ops when it comes to solids control. I know there's a couple companies. I'm not going to put names out there, but there's one particular who's very big on technology, and even a couple of years ago said they could run it from an iPad back at the office, which I think that's the future. If you don't need someone on there except for to repair it, that would be nice. But anyway, that's a long-winded answer.
No, I mean, I think you're right, though. It requires monitoring, and I think in the same way, I mean, look, if you're a mud engineer and you don't take the mud weight of the effluent and, hey, is it 9 pounds or whatever? Like, what kind of cut am I getting? Is this doing anything?
No.
And if it looks terrible, like I said, is there an adjustment to be made, or do we take a break? But the other part of it, you follow your retort trends. I mean, you'll see if we're not running it enough, you'll see those as low gravity solids build. Right. With all of your other parameters being sort of typical, because you're still going to build volume, you're still going to do other things while you're drilling. But if you say, hey, I'm a tick up on low gravs again, like, we need to be more aggressive on the solids control. Those are conversations you have. I mean, I've heard stories of, in the Northeast where they drill so fast and those solids are so fine that customers have tried even up to 6 centrifuges, just hoping they could get enough throughput to address that challenge. And it's quite difficult, depending on what you're working on. Yeah. But I think also some of your comments about monitoring, I think that really is the future. It's because it's mechanical equipment. And you're adjusting settings, as long as you can take measurements and respond to those measurements, right. And so we're already seeing things like, hey, I'm looking at the torque on the bowl or the auger, and depending on what I'm seeing with load or whatever, I can adjust the speeds. I've seen some folks put Coriolis meters on the effluent and some other things where they can say, okay, well, I can tell the density coming out, and I can make adjustments to optimize. Yeah. They're relatively straightforward formulas. With that information, it's a pretty straightforward flow chart to dial it in, or at least start dialing it in, see what happens, and then make another adjustment. Yeah. So I really do see that as the future. I also see that we always have this tension on land where if you don't put the money into solids control, there's no reason to believe that solids control is effective, and then it becomes a race to the bottom. Yeah. Conversely, sometimes you'll say, okay, let's spend the money, let's get it right, and you'll find yourself in a place not long after where, you may not be able to get the people, or you may not, like you said, you don't get the operator who knows how to run the equipment, even though you have the nice equipment out there. It's not being run properly, and say, look, you shoot your shot and it just doesn't pan out the way that logic would dictate it should. And it's like, well, we didn't even give it our best shot either.
Yeah.
So it's complicated, but I hope more sensors, and I think they're relative in the grand scheme of the cost of a centrifuge and that sort of thing, relatively reasonable to start working those things in, and maybe improve what we know and improve our performance there.
Yeah, and this would be my challenge for the solids control world out there is, I've been on a rig where there'll be someone out there and they're sleeping throughout the night, and all they're doing is making sure the power's feeding the machine. And then others are out there working their tail off, and the equipment was exactly the same, but when they changed towers, it was the fluid performance was night and day difference. And so if we can get to a point, and let's be honest, like the solids control rep on location, like it's not a great job, right?
No, it's tough.
It's tough, and you're working and you're dirty and you're having people trying, I don't say yell and scream, but they're like, hey, we need this, we need that, and how come this? And it's a challenging environment to be in. And the sooner we can get towards, like you said, we're monitoring all the inputs and the outputs, and then somehow automating the adjustments, and then having someone there as, again, collecting data or maybe relaying information back to something, then I think we'll start seeing if solids control efficiencies really get some good momentum. But if you're relying on, the human element to dictate whether or not the solids control equipment's going to run well, it's a gamble on what you're going to get from, hitch to hitch, which is tough, right? And I understand why. I've been out there and seen it. It's like, that no wonder this person's having a tough time, because it's minus 30 and it's snowing and you're slopping around in mud and you're trying to bust hoses and fix things, and it's tough, right?
Yeah.
So anyway, I think there's a lot of room for improvement on that front, but again, it's who's going to spend the money to do it and go through the pain points. But nonetheless, it's an interesting conversation, and it's one that as mud people we just hope and wish that when we get on location that there's good solids control equipment and a good centrifuge that runs well, and we don't have to worry about it. But it can certainly make or break a mud engineer's hitch, if you will.
Absolutely.
So anything else, Matt?
No, I just thought running through the basics, and maybe we triggered a solids control guy or two to jump in and offer maybe a more sophisticated description or characterization of the life right now.
Yeah, no, that'd be great. And with that said, please reach out to us on LinkedIn, or you can reach us at the Flowline at AES Flowline podcast at aesfluids.com. Check out the website, all the tactics on YouTube, a ton of great information out there. With the holidays, again, be safe out there, and just a huge thanks to all the field folks out there making the sacrifice to provide energy to the world during the holidays. With that said, take care, everybody.
Take care.
Cheers.
Thanks for listening. Please tune in next week for another exciting episode of The Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.